Hello, everyone. Good morning, good afternoon, good evening, wherever you are, whatever your time zone, welcome. This is Digital Transformation Talk, and I am your host, Kevin Crane. Welcome to the show. We are here today talking about integrating OT and IT data in your manufacturing digital transformation. Integrating operational technology data and information technology data in manufacturing can offer several significant benefits. OT data typically refers to data generated by industrial processes and equipment, while IT data encompasses the broader realm of digital information technology. There are a number of advantages that can be found when integrating these two types of data in manufacturing. Improved visibility and insight is perhaps the most powerful. Integrating both operational and business data and the visibility it provides us is found in real-time monitoring and control of the process and enhanced predictive capabilities for things like predictive maintenance and optimized production and supply chain operations. By analyzing data from sensors and combining it with historical maintenance records and other IT data, manufacturers can almost literally predict the future, when equipment is likely to fail, when supplies will be needed, and so forth, allowing us to adjust parameters in real time and reduce waste. This, of course, can lead to improved product quality and operational efficiency. Of course, another top benefit is found in cost reduction. Through integration, manufacturers can identify areas where costs can be reduced, and they can optimize resource usage, reduce energy and consumption, and minimize downtime. And improved quality control is another top benefit. In my mind, it all comes down to better data-driven decision making. And this can lead to competitive advantage because we can respond more quickly to market demands, innovate more effectively, and deliver higher quality products at competitive prices. And look, all of this is not to mention the ability to foster collaboration between different teams within the organization and break down data silos that can exist between OT and IT systems. But in order to gain all of these advantages, it is essential to plan and execute the integration carefully, ensuring data security, maintaining data integrity, while eliminating siloed data and siloed processes. All of this is a tall order. Which solutions and approaches are best? And once we've adopted a more integrated approach, what are some best practices to realize the full potential? Well, that's what we'll be discussing today with a great panel of guests. But before I introduce our guests, I do want to say that we want to hear from you too. We'd like to encourage everyone participating today to attend and participate. Please join in with your comments in the chat section. And if you have a question along the way for our guests, please enter them into the chat feature. That's where I'll be looking, and I will attempt to get some of your questions into the flow of the show today. And certainly we'll have a few minutes at the end for your questions as well. All right. Let's bring aboard our great panel of guests today, starting with Greg Sloyer. Greg, are you with us? Ah, there you
Yes,
are,
thanks,
Greg.
Kevin.
Thank you. Welcome aboard. Greg is a manufacturing principal with Snowflake Computing. He's a manufacturing expert with over 16 years of experience in data and analytics, and prior to that, nearly 20 years in the chemical industry. One little known fact about Greg, though, is that he was in a jazz band that toured Europe, including playing at the Montreux Jazz Festival, and currently plays bass in a rock band in the Raleigh area. That's great, Greg. What is the name of your band?
Relics. Goes
Relics.
with the age.
Right. Absolutely. Well, if you're in Raleigh, you've got to check out the Relics. Thank you, Greg, for being with us today. Also with us is Chanchal Chatterjee. Chanchal, are you with us? Coming on board. Hello, Chanchal. Chanchal is a
Thank
senior
you.
deep learning software lead with NVIDIA. Now, Chanchal has over 20 years of experience in machine learning and indeed is the author of the book, Adaptive Machine Learning Algorithms with Python. But in his spare time, Chanchal uses ChatGPT to write business plans for really weird startup ideas like pet rentals and goat landscaping. Now, don't laugh. Goat landscaping is a thing here in the Pacific Northwest. Chanchal, are you planning to start a goat landscaping business?
No, that was just sent out as a joke. Yeah.
Well, I think you may be onto something there, so we'll stand by for that. Also joining us today is Nanda Kishore, head of global supply chain at Aramet Titanium and Iron. Nanda, are you with us? Ah,
Yes,
coming
hi
in.
Kevin.
There you are, Nanda. All right. Nanda is an accomplished supply chain executive with over 28 years of global experience in the automotive, heavy engineering, and manufacturing sectors. But look, Nanda is also an avid outdoor person and recently summited Mira Peak in the Himalayas. Wow, congratulations, Nanda. That's quite an accomplishment. The altitude of Mira Peak is over 4 miles high. What did the world look like from up there?
Looks beautiful. Only the air is very thin there, so you can't be there for long. But it's a beautiful place to be. I still plan to go higher and higher in next years.
Well, keep it up, top of the world. That's great, Nanda. Well, welcome, gentlemen. Thank you for being with us. To get us started, I'd like to direct our attention to an article published recently by Li Wei Hertz called The Future of Generative AI in Manufacturing that talks about how the manufacturing industry stands out as a prominent beneficiary of generative AI. It's really quite an extensive article that talks about the various Gen AI models that are being applied, particularly generative adversarial networks, or GANs, that are employed to create realistic data simulations and generate synthetic samples of products and materials and processes. These generated samples can be used for training machine learning models, testing product designs, optimizing the production process, and GANs can help in automating quality control by identifying defects or anomalies in real time. There are a bunch of other models explored in the article as well. And if you'd like to read that article, there is a link in the chat box. So please feel free to jump in there and check that out. But my question to the group is really, what do you feel the role of generative AI is and will be in manufacturing? And what are some of the main impacts to manufacturing and supply chain operations? Let's start with Greg. Greg, what's your take on generative AI in manufacturing?
I think it's ever changing, and it's and the speed in which it's changing. So if we have this same conversation in 2 months, we may be all shaping our answers differently. But I think what we're seeing here is that incredible usage of these kinds of advanced mathematics and compute really capabilities, enabling a much broader set of users than we've experienced. So really taking it out beyond the data scientists, and the article mentions this, going beyond the data scientists and really extending that effort and capabilities beyond folks that were trained specifically for that. You mentioned in your intro a number of different areas between predictive maintenance and quality and those aspects. I think as we start expanding the data sets and foundational data, IT and OT convergence, really building those models on top of the broader data sets, incorporating not just I'll say the inside IT and OT data, but third-party data into those. I think that's where we're headed, in terms of use of those models and the expansion across the organization.
Yeah, really empowering. I mean, good data equals good decisions. Really powerful developments. Chanchel, you're an expert in machine learning. What's your take on these models, GANs, for example, in training machine learning models?
That's an awesome question. I've actually used a GAN model for a actual machine learning application for a very large oil and gas company while I was at Google, and it is a published resource. It's a paper that was presented to NIPS, and those of you who are listening, you can search for the paper. It's called 3D Conditional Generative Adversarial Network to enable large-scale seismic image enhancement. So I guess it will not be a secret if I mention that because the co-authors are from Chevron. This was a very large three-dimensional images of subsurface, and we used a generative model in order to enhance the images. The project was actually much more extensive than that, but the whole idea of the first phase was to enhance the images so that you can find subsurface artifacts for oil and gas exploration. This is a real concrete example of GAN that was used there.
Big time. All right, very good. And Nanda, before we move on to our discussion points today, just really quickly, what's your take on the future of manufacturing with respect to generative AI?
Yeah, as you know, I come from an industry background where I'm mostly on the user side of these things, and two things I've been really very happy about it is that generative AI has sort of widened the community of AI solution providers. Into, hitherto was restricted to data scientists, as Greg also mentioned, and most importantly, I've seen that it's getting wider popularity in terms of using in supply chain optimization. So that's my pet area where we are seeing increased usage. And I think the future is it will be much easier because so many are developing different models to adapt to their own specific industries. So supply chain models in terms of helping the inventory management to get the right items at the right time at the right level. So all right. So this is where I've seen the usage of it. And one other example, as Chinchal was talking about oil and gas, and one of the other things, but as you mentioned about, I'm a mountaineering person, so I've seen the use of this generative AI. From, if you see this, what's it called, a documentary from National Geographic, I don't know, for some time back. So they use this. It's very nice to see the videos. They used it from Everest Base Camp to a very high altitude in terms of mapping the whole terrain. And then they also taken samples out of that. So next in few years, it will clearly talk about the changes in climate because we never know what's going on because that has two things, the history of 1,000 years back and the future also. So every small changes will be noted in the climate change. And I don't know if many people are aware, we are talking about 7.5 billion liters of glaciers are melted every year in Himalaya. So imagine if there is a slightly more or less, it has a huge impact on billions of lives, depending on the water and other systems there. So this is very interesting, and this is going to evolve. Even as we speak, things are getting changed in the generative AI world.
All right, very good. All right, well, let's get into our discussion points today. We are here today to talk about integrating operational technology data and information technology data. Gentlemen, it seems to me we're talking about integrating data, which is always a huge issue. To me, it seems like there tends to be a silo between operational technology data and information technology data. And the importance is integrating those two and bringing them together in a system that allows us to take advantage of some of these advantages that I've talked about. From your points of view, how do we eliminate those data silos to drive supply chain transformation, manufacturing operation efficiency? Gentlemen, I'll leave it up to you folks, but Greg, perhaps we can start with you and then we'll move into an open discussion. How do we start to eliminate these data silos that may inhibit our innovation? Greg?
So let me start with something that's not technical. It's trust.
Okay.
We grew up through manufacturing for the last many decades where the manufacturing facilities, the shop floors have been isolated, both organizationally in a lot of cases, as well as from a system standpoint. And now the systems are at the point where they can handle all of this data and the speeds and things like that that are required. But we still have a lot of organizational security, components that we've got to take into account as we look to integrate this data. And the OT side of things is, we talk about the sensor data, but there's a number of other shop floor systems. When I'm talking with folks and I ask them the number of plants they have, sites, and they have 50 plants, and I say, okay, you probably have 48 different historians and LIMS and MRO and other sets of systems out there. So getting a handle on that, bringing that data together, being able to trust the quality of the data, that the organizations also have the trust and the security in the systems. I think that's key into starting that process if you've not gone down that journey already.
All right. I think those are some important points. Now, Chanchal and Nando, I'll just open it up. How would you recommend that we start to eliminate these data silos that may inhibit our innovation? What's your take on this, gentlemen?
So the method that, I'm this Chanchal, I'm sorry, did I speak over Nand? He can go
No,
ahead
no,
if
no.
you
I
want.
was pointing that you take over.
Okay, no problem.
Go ahead, Chanchal.
Okay.
Yeah.
Yeah, so I'm a meat and potatoes guy, so I would like to get to the specifics quickly. So there are a couple of techniques that we use. These are typically known as orchestration techniques. One is called based on a open source called Apache Airflow. The second one is also based on an open source called Apache Kubeflow. So data can come from warehouses, it can come from temp resources, it can come from live sources. And there are various interfaces like Kafka in order to acquire the data, but that's not the main problem. The main problem is that how do you take these multiple sources of data, screen them? Some might be numerical, some might be text, some might be uh, documents. How do you take these multiple sources of data and you process them, pre-process them, and you integrate them into a single platform so that they're useful for a real-world application? So Apache Airflow is a great example of integrating. They're both based on what is called DAGs. DAGs are directional acyclic graphs. And you can create nice components based on Dockers, which can do processing as intermediate steps so that you can eventually integrate them together. So this is the architecture that we used a lot at Google in order to take multiple sources of data and integrate them.
And Nanda, you're a supply chain expert. I mean, it seems to me that this would be supply chain optimization and data integration across the supply chain. That's a huge challenge. What is your experience with this?
It is. I agree with that. And Chanchal touched upon one of the ways of mitigating these data silos by using data integration tools. In my experience, I think I would suggest that the first and foremost is to create a unified data platform. That can seamlessly collect, store, and process data from both OT and IT sources. And we have these middleware solutions like data lakes or edge computing. They can use that. I think that's like a basic thing to be done, especially when you're talking about complex end-to-end supply chain requirements. And then, of course, we need to have I would say the company needs to have a robust data governance policy to ensure that data quality, security, and compliance are sort of coming under a top umbrella, not separately for OT or separately for IT teams. And then, of course, we need to ensure the cross-functional collaboration between the OT and IT team. So as Greg mentioned, it was earlier that the shop floor guys, we were sort of isolated from all the admin guys. So they did all the IT work. We had no idea what was happening. So now we are talking about OT IT instead of blue and white colors. But I think the teams have also sort of grown up to be a little isolated. But I think it's the time now to integrate them, make them work on a cross-functional platform, and then treat data as one data from one end to another end instead of this is OT, this is IT, and then struggle to mix the data. So that's from my sort of life experience.
Yeah. Greg, you're shaking your head. You have something to add there?
No, I mean, I agree exactly with Nandel and Chanchal on what they said. I think where the considerations come in twofold. You've got a number of different protocols on the shop floor. So you've got to have a mechanism to bring that data in. There's hundreds, and there's an efficiency. We've chosen as one method, MQTT as a protocol to convert things to bring that in and really save on the transmission as well as the storage side. So all these kinds of considerations come into play to get that data from the multiple sites, bring it together and put it, let's say traditionally time series data together with more of that transaction, or let's call it event type looking data. And then, putting the analytics, a lot of this AI and ML that we've been talking about on top of that, really bringing the power of that compute to that data.
Well, let's talk about the advanced analytics part of it. I think this is where the rubber meets the road in terms of making better decisions and optimizing the process. Advanced analytics for supply chain and operations. What are some of the analytics that we should be considering? I've got a more unified approach now with my sensor data, my IT data, my other data that is around in the organization. I've got a platform and an approach to unify that data, but now I need to put it to work. Gentlemen, what are some of the analytics that you might recommend that are especially powerful in the industry, and what should we consider about them? Do you have suggestions on which analytics are the most powerful that we should consider?
Let me jump in real quick before we hit the mathematics.
Okay.
Let me provide one caution with that data. Now that you've got it together, great. The key for any of these mathematics, I don't care what model we talk about, is the data quality. The square root of a bad number is a bad number, no matter what you do. It's just the way it works. And we can make bad decisions faster if we don't have a handle on the quality. And the quality is not just a systems things, it's a process issue. If you're dealing with less than 85% inventory record accuracy and your manufacturing schedule adherence is not good, I'll say those quote unquote simple, ancient now almost metrics, the models are not going to be any better. You can use the models to help find some of those inaccuracies. We can definitely clean up the data, but I'm going to make a pitch for data quality being a foundation, and now we can talk about the mathematics.
Yeah, let's just skip over all of that. Yeah, sure. Assuming data quality, yeah, garbage in, garbage out for sure. All right, but how do I get the real power out of it now? Nando, what's your experience in supply chain?
So for me, it's more important that any of these data, the systems or ERP systems or any of them, they have access to real-time data. Because when it comes to inventory or orders and then transit working process, if the access to the real-time data is not there, then we are sort of a lag in the decision-making process. So for me, it's very important that the real-time data access is there. And a couple of things on the analytic techniques, I would say, which have been used and come across is predictive maintenance. I think some of them are from manufacturing background will understand this. Predictive maintenance of the machines based on sort of a lot of predictive data instead of, so that sort of has an input or an influence on what we call as S&OP process. Because when you talk about the sales and operations planning and you do not consider your maintenance shutdown or planned maintenance thing into the whole planning system, and over a period of a quarter or over a period of half year, you have a big impact on the mismatch between the sales and the requirements of the demand and the inventory. So I think this is very much important in terms of predictive maintenance and demand forecasting. So these are the two areas which I'm seeing we are using this analytics and to a greater success. But the key is real-time data access.
Real-time data access and data accuracy, as Greg has mentioned. Yeah, okay. Chanchel, what about using this data for things like product prototyping and that sort of like almost predictive, but really prototyping the product itself? What is your experience there, and what should we consider with respect to that?
Awesome. I'll give you an example of a real product, not just a prototype.
Okay, very good.
So taking multiple sources of data, pre-processing them, and making it work on a real application. So there is this company called Xenos, starts with the Z as in zebra. And while I was at Google, we did a project with them, and it became a blog, and it became a public press release. So this is a project in which we did event monitoring with explanations. We did it on the Google Cloud. And this project became very successful, and the customer went ahead and turned the switch on and went into full production. So the way we did that, we had multiple IT and OT data, okay? And this falls in the territory of AI ops. We were monitoring multiple different data center equipment trying to do predictive failures. But to cut a long story short, you can look up the blog and the details of how we implemented. But the whole orchestration framework, which I mentioned before, was with Kubeflow pipelines and not Airflow. So Kubeflow and Airflow are two technologies that you can use. And we did the pre-processing of multiple sources of data. The second step was that we did segmentation or identified input sources that were similar in nature that we call cohorts. So we created, there's a nice graphics in the blog, which you can see. We did the cohort identification, then we launched a generative AI technology in each of the cohort based on an open source code called MADI, M-A-D-I, which you can also search. It is in GitHub. And then we aggregated the result and then we provided the explanation. These were the 5 steps in which we achieved this whole thing.
Nice.
So the data preparation and aggregation is the first thing. Identification of similar data sources, which is cohorts, is the second thing. Launching different the anomaly detection. This is unsupervised learning in each of the cohorts and aggregating the data, and finally provided explanations. Explanations are provided also by Google's own technology called integrated gradients. It was very successful. It is in production right now, and the company was very happy with it.
Nice 5-step process there. That's fantastic, Chanchal. All right, we are here today with Greg Sloyer, Chanchal Chatterjee, and Nanda Kishore. We're talking about integrating OT data and IT data in manufacturing for digital transformation. If you have a question for our panel, please feel free to enter that into the chat feature, and we will attempt to get some of them into the flow of the show. We'll certainly have some time here in just a bit for your questions. All right, gentlemen. Now, we've talked about analytics. We've talked about data silos. Let's bring this all together. And of course, that discussion of bringing all this together couldn't be had without talking a bit more about AI in general and how to bring AI into a smart manufacturing practice. Certainly, AI has been on the minds of everyone here recently, but it's in manufacturing really not necessarily a new thing. From your experience, gentlemen, how should we bring AI into our manufacturing process, and what are some of the best practices to consider? I'll leave it up to you folks. Anyone have some suggestions about how to bring AI into our process in ways that are practical and effective?
I can start.
Go ahead, Ned. Go ahead. No, you go ahead.
No, because I have very few things to say.
Nice.
So I think bringing it together means utilizing machine learning algorithms for predictive maintenance, quality control, and process optimization. I see that there are the examples and cases are increasing day by day in manufacturing industry, but I think that's the very sort of low-hanging fruits, and it yields a quick result when you implement these things, because predictive maintenance, quality control, and process optimization are like 3 pillars in an operational excellence world. And of course, another thing is the usage of incorporation of IoT devices like sensors and devices on the shop floor, but be able to measure them and also access the data on a real-time basis from these things. I think this is from my experience and exposure. I can say this is how we can sort of bring all together and increase the usage of AI and generative AI. Sorry, Chanchal,
Sensor data. What's some of the sensor data that you're collecting? Manufacturers collect. I'm curious about what that sensor data is and what that tells me.
So it depends on different type of industries. For example, in a metallurgical industry or a petrochemical industries, you have a lot of sensors for heat data collections, because you need to optimize. For example, if you're talking about a furnace or a smelting furnace, so you need to have the exact temperature range to bring it up to make sure the quality of your product is accurate. Because if you're a little bit vary plus minus 50 degrees on your temperature on the furnace, your product quality will be something different, because it's a chemical reactions. which sort of isolates the atoms and isotopes into the right combination. So there it's very predominantly used, and it's gaining more importance because you can accurately predict the quality of the product. And before people start wondering what's melting and smelting, I will just give a very simple definition. Melting is where you convert a solid into a liquid, but smelting is where you sort of take the mineral to a certain temperature to get a best quality or the most quality product out of it. So that's the difference. So I'm talking about when you're talking about smelting, so you have to be very accurate in your temperature control so that your quality of the product is up to 90%, 95% accurate. So
Nice.
that's one example of sensors usage.
Nice. All right. Well, Greg, what are you folks at Snowflake? How do you approach this, bringing AI into the operation itself? What's your advice?
So a lot of what Nanda said, absolutely, that's what we run into: quality, use, predictive maintenance, cycle time, a lot of root cause types of analytics, especially when you look outside of a single component in a production line. If you've got multiple robotic arms and chillers and presses and pumps and things like that are throughout a very long, let's say, production line, looking at things in isolation is not going to, that's sort of the foundation. You'd start looking at things in combination, looking at how, an upstream impacts a downstream component for all of these kinds of analytics. And that really requires that AI and ML, it's just too much data, too many interactions to do this manually. It just, you really cannot optimize and look at all those temperature components to the smelting process that Nanda just said, without looking at the 3 and 4 and 5 steps ahead of that to incorporate those variables into that decision process and those analytics. So that's one part. So being able to bring that power to that data, with AI and ML and more advanced analytics. The other thing I'm going to highlight besides the math is there's a change management process that also needs to occur. If you're going from spreadsheets or backs of envelopes and whiteboards, jumping to AI and ML without doing, let's say statistical process control and more of those other types of analytics, that's a difficult leap. We tried that with optimization models back in the mid to late 90s, and those didn't work well on the manufacturing shop floor because they were just too, folks did not understand the answers and they didn't believe them. And they tended to fail more often than they were successful. So I'll just highlight, make sure you're bringing the organization along with those analytics. Don't just force the analytics in and assume that the actions taken from the analytics will be the right ones.
Yeah. Good point. All right, gentlemen, it's time that we get to some of the questions that are coming in from our audience. Thank you, everyone, for your participation. This question from Lauren West, I think, brings up the human side of it. How do you address the challenge of a shortage of AI talent in manufacturing? Chanchel, what is your take on this question from Lauren?
So in my opinion, the algorithm part of AI is becoming more and more generic.
Yes.
So that is why I think a lot of the algorithm talent will, they're still needed, but not in as huge a quantity as we needed before. So I think the biggest challenges in manufacturing lies in the end-to-end integration of AI solution. Which is the data preparation, the pre-processing of the data, the model training, the model storing, the model explanation, that whole pipeline. This falls in the area of what is called MLOps. And I think that's an area also. MLOps packages are becoming more and more prolific. Monitoring a model is another step. I do want to mention that we have since Nanda Kishore mentioned IoT devices, I just want to quickly mention that poses a new challenge because the edge environment does not have enough memory, enough compute, enough storage, and therefore you have a new challenge of how to pre-process large volumes of data at the edge. If you start uploading all the data from the edge, that will consume huge bandwidth and is expensive. So anyway, to answer your question, I think MLOps talents is more valuable in terms of end-to-end integration of ML solutions. In terms of edge pre-processing, these are analytics techniques. Actually, the book I wrote on adaptive machine learning with Python deals entirely with pre-processing of data at the edge in a low compute environment. The answer is that you do not necessarily need all ML talent in order to solve these problems. You need integration talents is more and more important.
Yeah.
Interesting that here we are talking about artificial intelligence, and yet one of the roadblocks to our success with artificial intelligence, which in many ways eliminates the human from the process, is the fact that we don't have qualified humans, or there's a shortage of talent to make all this happen. Gentlemen, is there really a shortage of AI talent? It seems to me that there would be many folks that would be qualified and interested in jumping into this field. From your experience, do we really have a talent shortage in the area of AI? Greg, your thoughts?
Well, I think it goes back to the question, is where is that talent? Is it on the manufacturing at the sites, in the shop floors, versus is it, where is that talent going? So it's attracting I'll say that the more data science trained, not necessarily data scientists, but data science trained folks to those shop floor manufacturing, process engineering type positions. That becomes the challenge, and we're seeing that in a number of different industries. Manufacturing, I think, is one of them, at least within the States. So, having them with these really cool problems, being able to leverage the tools that are available, looking at understanding the use cases, because that's the key difference between, let's say, manufacturing process engineers, those folks trained to some extent on the usage of the ML ops in those areas, versus the pure data scientists, is they understand that manufacturing environment. They understand the capabilities. They're the ones who then, the models don't save the money. It's the actions taken from those models. So cost and value all comes from the actions. Those are the folks who can translate, into actions and make those decisions. So I think it's that combination that we need to attract the talent down to.
All right, Nanda, do you agree?
Yes, I was thinking about what Greg was saying earlier. So probably Chanchalis and Greg are better to say about the actual AI talent. But what I think will be missing for quite some time is the talent to manage the change. Change management talent is something which we have to nurture. It's not readily taught in any schools and universities, and that's very, very important. And we'll be missing it for quite some time. As an example, I was actually smiling when Greg was talking about the transition from Excel into AI. I still remember the time when some of the folks I was working with could not really understand the beauty of this predictive data and analysis. So they sort of exported the data into the Excel sheet and then created pivots and then started to talk from the pivot instead of the readily data available with different scenarios. So that the change management, even though we implement AI, it can be sort of overcome with the talent, but to manage the transition in a specific industry, that's very, very important. Otherwise, we'll be talking about talent shortage for quite some time.
Right. Very good. We have been speaking with Nanda Kishore, Chanchal Chatterjee, and Greg Sloyer. And gentlemen, we are nearing the end of our session today, which brings us to the action item round of our program today. I'm wondering if each of you could provide us with one quick action item that our audience can do to take advantage of the ideas and advice today? Chanchal, I'll start with you. Do you have an action item for us?
Yeah, I think the main action item is to understand the types of data that are needed in your particular applications, and therefore build an end-to-end AI platform that is suitable for your solution. I would recommend that you start from packaged solutions rather than build your own. So, like Apache Airflow or Kubeflow orchestration, use open source as much as possible. The main challenge comes in the pre-processing part, which is the integration of IT and OT data, and which is particular to your use case because the data types are very different. So that has always been kind of DIY part of the ML. The rest of it can be easily packaged and can be solved very easily. So I would say focused on the pre-processing and the types of data you need and the integration. The topic of the discussion today, how can you package that easily with open source tools?
All right, very good. That is Chanchal Chatterjee, Senior Deep Learning Software Lead at NVIDIA. Thank you, Chanchal. Nanda, do you have an action item for us today?
Yes, mine is more strategic based. So I would say for industries trying to adopt or in the process of adopting, to continuously assess and update your strategies to stay aligned with the industry best practices and evolving technologies, while considering the specific needs and challenges of your manufacturing environment while implementing these solutions. I've seen many companies not see the success they hope for because they're sort of trying to implement which was implemented somewhere else, thinking that suits us. So be specific to your own needs and then continuously update the strategies. I think that's the way forward. One of the actions from my end.
Nice. Thank you, Chanchal. Chanchal Chatterjee, Senior Deep Learning Software. I'm sorry, Nanda.
No, that
I'm
was
thinking the wrong person. That is Nanda Kishore, of course, Head of Global Supply Chain at Aramet Titanium and Iron. Nanda, thank you so much for being with us. And finally, Greg Sloyer. Greg, do you have an action item for us?
Sure. We've talked about a number of different things here. I think in filling out what Nandel and Chanchal said, there's a data foundation component. That does not imply that you bring all your data together for years and years and years and then start doing the use cases. Align those with the use cases, especially as we start looking at IT and OT combinations. Look at those. That drives the speed, the types of analytics, the types of data. Bill Johnson had a question about the training, and we talked about data quality. So let's assume that's in place. And you've got that foundation together, then I'll say be open to the perspectives that you don't have all the data. Everything internally may have been perfect quality, timely to support the use cases, but let's say weather is an impact on your manufacturing, humidity, things like that, going back to Nanda's, adjustments of pressures and temperatures and things like that as part of the smelting process. There's data that may be missing, and that may lead to the models not being as effective as they could be. So be open to that data foundation, supporting use cases, building towards that, and expanding the use of data to support further and further use cases.
Very good. That is Greg Sloyer, Manufacturing Industry Principal at Snowflake Computing. Greg, Chanchal, Nanda, thank you so much for being with me today. What a great panel. Your perspectives and advice were spot on. Thank you so much. I hope we'll get a chance to talk again soon. And to everyone joining us today, thank you too. Please join us next time on October 24th at 1600 British time, when we will talk with another great panel of experts next time about aligning data solutions with business goals for a successful digital transformation. That should be another great discussion. And if you'd like to find me, you can do so on LinkedIn. I'm happy to connect there. Check me out. I'm Kevin Crane. And you can check out my weekly audio podcast, the Digital Transformation Podcast. But that will do it for this episode of Digital Transformation Talk. Thanks again, and until next week, I am Kevin Crane. Thanks for watching.